Welcome to this video. So in today's lesson, we're going to look at the continuous variables and also their distributions. Okay, so with me, I have a tutorial sheet on um, questions on different concepts under continuous probability distributions. So we'll start from how we can find, how we can prove, okay, that something is a valid PDF. And then we'll look at how to find the CDF of a continuous random variable, as well as how to find the probabilities, the expected values, the variance, and even how to use the linear relationship, okay, or the linear property of the expected value, as well as the variance. Okay, and then we'll also look at some uh, continuous distributions. Okay, so you can see here, like from this question 5, this will be on the uniform distribution. So we shall solve all these questions here, and then the other distribution that we'll look at in this video, or as we solve this tutorial sheet, will be the exponential distribution. Okay, so that's those are the questions that are in this tutorial sheet, and we're going to solve all of them. Okay, from question 1 all the way up to question 11. So we can start from the first question. Okay, how to prove that something is indeed a PDF. Okay, so a PDF is just the representation function that represents a continuous random variable. Remember, when we're talking about the discrete, we said those are represented by the PMF, right? The probability mass function. So those probability mass functions, when you're talking about the discrete random variables, they were valid at specific points. So meaning X was valid at the specific points. Okay, but now when we come to continuous, we're going to see that this f of X, the PDF, will be valid on an interval. Okay, so you can see even from the definition, the way they're defining it. So let's start solving them. So question 1, they're saying a continuous random variable X is defined by the function below. So this is a piecewise function that tells us that from 1 to 5, okay, the value of this function is 1 over 168. And then in the brackets, we have x to power 3 plus 3. Okay, and then elsewhere, it's 0. So this simply means that if I have x values, okay, that are less than 1, then my f of x will be equals to 0. If I have x values that are greater than 5, then my f of x is also equals to what? To 0. That's what this 0 elsewhere mean. Okay, it's only defined from 1 all the way up to 5. Okay, so that's the function that we've been given. And then the first one, they're saying verify that f of x is a valid PDF. And then B, find the cumulative density function, which is the CDF of x. Okay, so how do we verify that something is a valid PDF? Okay, well, we have to consider two important properties of a PDF. Okay, so the first thing is that a PDF should be non-negative, okay, for all the x in the specific domain. Okay, so we see here that if we pick any x within 1 to 5, this thing will always be what? Positive. So this is satisfied. And then the other one is that when I integrate, okay, this f of x over all the interval that I have here, okay, this should be equals to 1. So we're going to use this property here in order to prove that this is a valid PDF. So if I integrate this guy from 1 to 5, okay, and I get 1, then we're going to say that yes, the f of x there is a valid what? PDF. So let's do that. Okay, so we're going to integrate this guy. So it will be the integral from 1 to 5 of 1 over 168, and then x power 3 plus 3, and then dx. So this will be equals to, okay, so we can take the constant, this guy, outside the integral. So it will be 1 over 168, then the integral of 1 to 5 of 3 power, x power 3 plus 3, and then dx, right? Okay, so here we're just using the power rule to integrate. Okay, so this will be 1 over 168. Then in the brackets, I can integrate this now. So integration tells us that we add 1 to this power, okay, and then we divide by that same new power. So if I have 3, the way it is here, if I have 3, a constant, the way it is, it means this one has x to the power 0. So to integrate it, we're going to add 1 to this power, okay, and then divide by this new power, which is 0 plus 1, okay? So here, on the x to the power 3, we're going to add 1 and then divide by the new power, which is 3 plus 1. So this one becomes x to the power 4, if I add 1 there, and then I divide by the new power, plus this guy here becomes 3x over the new power of x is just 1. Okay, and then I'm evaluating these from 1 all the way to what? To 5. So that's what I have. Okay, so what am I going to get there? So you just have to substitute. So this will be 1 over 168. And then in the brackets, we're going to have, wherever there's x, I put 5 now. So 5 to the power 4 over 4 plus 3 multiplied by 5 divided by 1. Okay, and then minus 5. Oh, no, we're done with 5. Now we substitute the 1. So 1 where there's 4, so that is 1 to the power 4 over 4. And then plus 3 multiplied by 1 divided by 1. So that is what we have there. So what are we going to get once we do that simplification? Okay, so you just get your calculator and then try to find those values. So the first one is, I have 168 here. Okay, and then I have 5 to the power 4. 5 to the power 4 is going to give me 625 over 4 plus this 3 multiplied by 5, that is 15 over 1. Okay, and then I have minus here. So these ones, you should put them in brackets like that. So that is minus, and then in brackets, I have 1 over 4, because 1 to the power 4 is just 4. So this is 1 over 4. And then plus 3 multiplied by 1 divided by 1, that is 3. So this is what I have here. Okay, so let's calculate whatever we have in the brackets. So this is, if you want, you can just punch them on the calculator and then you see what you're going to get. Okay, so I have 625 divided by 4, and then I say plus 15 minus 1 divided by 4, and then minus 3. Okay, so this gives me 168. So 168 multiplied by 1, get 168 divided by 168. So this is just 1. So we see that the integral from 1 to 5 of my f of x dx has integrated to 1. Okay, so this one proves that indeed this function here is a valid what? PDF. So that's how you verify or prove that something is a valid PDF. We have shown that it integrates to 1. So it's a valid PDF. Okay, so meaning that if our answer was not 1, then we would say that the function that we've been given is not a valid PDF. Okay, so we are done with that one. And then let's find the cumulative distribution. Okay, let's find the cumulative distribution. So now the cumulative distribution is just the probability that the random variable x, okay, is less than or equal to a certain value k. Okay, or we can say t. This here is what we call as the CDF. So in other words, we are just going to replace to represent it by f of t, like this. Okay, so whenever you see something like this or something like this, it's the same. Okay, and also the probability of x less than t is still going to give you this f of t. Why? Because when you are talking about the continuous random variable, okay, the probability at a certain point is always 0. So if, for example, I have the probability of x equals to whatever number like this, as long as this x here is a continuous random variable, then this probability here will be 0. Because we said the continuous random variable is not defined at discrete values. It's only defined on an interval. Okay, so meaning at specific points, the probability is always 0. So whether I have less than or equal to or less than or greater than or equal to, I always get the same answers under the continuous random variables. But under the discrete random variables, it will be a different case. Okay, so now what is the formula of this CDF? Okay, so the formula for the CDF is that it is the integral from minus infinity all the way up to t of the function f of x and then dx. Okay, so this minus infinity here should not confuse you. This minus infinity is simply the lowest number that you have in your interval. So for example here, the interval is from 1 all the way up to 5, right? So the lowest number that I have is 1. It's the one that I'll place here when I start finding my what? My PDF, my CDF, I mean. Okay, so that will be the formula that we are going to use in order to calculate the CDF here. Okay, so now we have to be very careful when you're finding the CDF because this is the CDF of a piecewise function. Okay, so it means we have to find the CDF for each interval that we've been given. Okay, so this is what I mean. So this function that we were given there, okay, remember I said it's only defined from 1 to 5. So meaning that there's some parts that it did include. So this PDF is 0 if x is less than 1, okay? And then it is 1 over 168, and then x to the power 3 plus 3 if the 1, if the x is between 1 and 5. And then it's also 0, okay, when x is greater than what? 5. So when finding the CDF, because the CDF is commutative, right? So we have to find the CDF of this, the CDF of this, and the CDF of this. So meaning that even our CDF will be in terms of a piecewise function. Okay, so what are we going to do? We start with the first one. So remember, we said CDF f of t is the same as the probability that x is less than or equal to some value t, okay, which is the integral from minus infinity, the lowest value in the interval, all the way to t of the f of x and then dt, right? Oh, dx, not dt. Okay, so here we're going to start with the first one, this one here. Okay, so the first one, that's just the commutative frequency that x is less than or equals to what? The 0 there. Okay, so the limits are from the lowest possible value, which is 1, to t. And then our f of x within this interval is what? It's just 0, and then dx. So when your integrand is 0, then it doesn't matter. Whatever you do to that, it will still be 0. Okay, so the first commutative, the first CDF when x is less than 1, it's just 0. Okay, so why is it that? Because before x is equals to 1, it means the function hasn't yet started accumulating because we are told it's 0 elsewhere. Okay, so the CDF for this part here is just what? 0. Okay, so now to find the CDF of the next part, we need to add this CDF and then find this CDF because it's commutative. So what I mean is that, okay, the CDF now, okay, the CDF now, f of t, that x is less than or equal to a certain value t, okay, for this interval now, it will be the integral, okay, from, remember x is less than t. So x being less than t simply means that when we want to get the CDF of this part here, we also have to add the CDF of that part there on top. So it will be the CDF of this part, which is what? Which was just 0, right? So I can say 0, okay, and then plus the CDF, okay? Or maybe we write it in terms of an integral. So this guy here was from um, from 0 all the way up to 1. If we write it as a probability function, because, oh, no, from minus infinity all the way up to what? To 1. When I consider x is less than 1. So this is the interval minus infinity all the way up to 1. So since we're finding the CDF, then we have to add the probability of this to the next one, right? So this is what I'm doing there. So 0 dx was for the first one, and then plus. Now, the CDF now that I'm finding is for this guy. So it will be from minus infinity, which is just the lowest number in this interval. So that is 1, okay, all the way up to t. And then I write 1 over 168 x power 3 plus 3, and then dx. So this is what I have. Okay, so this part here just gives me 0 there. So that would be 0 plus. And then here I have to integrate. So I can say the 1 over 168 goes outside. And then the integral of this just x to the power 4 over 4 plus 3x divided by 1, which is the same thing, and then t minus 1. Okay, so this will just give me 1 over 168. And then I put in my t. So it will be t to the power what? To be t to the power 4 over 4 plus 3t. Then I put in my 1, that will be minus 1 over 4 minus 3. Okay, so that will be my CDF for the part 1 to what? To 5. Okay, I can now combine this minus 1 over 4 minus 3 over 1. So when I combine it, I get 4 minus 1 minus 12. So this will be minus 13 over 4. So it means the CDF, okay, from 1 to 5, it will be this guy here. So let's write it properly. So that is minus 13 over 12 that we found, right? So the CDF from 1 to 5, it's 1 over 168. Then in the brackets, I have t to the power 4 over 4 plus 3t minus 13 over what? 4. Okay, so this here is the CDF from 1 to what? To 5. And then now we can find the CDF for values that are greater than 5. Okay, so we're going to say the CDF for values that are greater than 5 is equals to the probability of this plus the probability of this, and then the CDF, and then the probability of that one. So it will be the integral, okay, from minus infinity all the way to 1 of 0 dx plus the integral of 1 to 5 of this guy, 1 over 168, and then x to the power 3 plus 3 dx, and then plus now this guy. So this will be 1 at 1, 5 to a certain value t, because we're finding the CDF, right? And then the integral is 0, and then dx. Okay, so what we notice here that this guy is going to be 0 plus this one we showed on question A. Okay, when we integrate over the O interval that it is defined on, this guy here gave us a 1. And then plus this guy, because the integral is 0, it's just going to give me 0. So this one will just be 1. Okay, so meaning that the cumulative probabilities after all the probabilities in the defined interval is always equals to 1. That's just what we are showing there. Okay, it's just equals to 1 when you add all the probabilities, because this function here is only defined from 1 up to 5, right? So meaning when I add all the probabilities from 1 up to 5, I should get a 1. Okay, and then since this is 0, any probability outside the 5, it means we have added all the probabilities by then. So it will still give us a 1. So this is the 1 here. So it means the CDF for this part here is what? 1. Okay, so now to write the final answer, you're going to write it in this form. You're going to say my CDF, hey, that's to be capital letter F. My CDF, okay, f of t is equals to the piecewise function 0, okay, when x is less than 1. And then 1 over 168 t to the power 4 over 4 plus 3t minus 13 over 4 for the interval 1 to 5. And then it's 1 for x is greater than what? 5. So this guy here that I've written there, okay, is our, oh, I've mixed up the variables now. So if you use t here, make sure that even there you use t. If you use x, make sure you use x everywhere. So I can go back to my x. It's just a change of variable. It doesn't change anything. Okay, so I can say this is x, and then this is also x, and then I put x. So my CDF of x is just this guy here. And then you are done with finding the CDF. Okay, so let's move to the next question. Next question, we're finding probabilities. So they're saying using both the CDF and the PDF, find the following probabilities. Okay, so I'm going to use both, and then you're going to see that one of them is very simple. Okay, so this probability simply means the integral, okay, from the lowest point for the defined interval, because they were given what? We're given this PDF. F of x is equals to 1 over 168, then x to the power 3 plus 3 for 1 less than or equal to x, which is less than or equal to 5 there, and then elsewhere 0. Okay, so this probability here that x is less than or equal to 3 is the probability that x comes from the lowest point in the defined interval. Okay, so that point will be what? It will be 1, then it will go all the way up to 3. And then I have my probability function there. Okay, so I can find this probability by using this formula. So let's find it. So it will be 1 over 168, and then I integrate this. Okay, I evaluate them at 3 and 1. So this will be 1 over 168, and then I have 3 to the power 4 over 4 plus 3 multiplied by 3 minus 1 over 4 minus 3. So this is what we have here. Okay, this is what we have there. And then we can just punch this onto the calculator to see what we're going to get. Okay, so we're saying 3 to the power 4, that is 81. So I'll say 81 divided by 4, and then plus 3 multiplied by 3, that is 9, and then minus 1 divided by 4, okay, and then minus 3. So that gives me 26. So that will be 1 over 168, and then I have 26. So I can divide this. So 26 divided by 168. Okay, so that is giving me a probability of 0.154761904. So this is the probability that the x is less than or equal to what? To 3. So this method that we've used here is the PDF method of finding this probability. But we can also find this same probability here by using the what? The CDF. Okay, so let's try to use the CDF to see if we're going to get the same answer. Okay, so by the CDF, we know that this here is the same as f of 3. So meaning in the function of f, okay, wherever there's x, we're going to replace by 3. So what did we find as our fx? Okay, our fx is this guy here within this region here of 1 to 5. So in here, I'm going to put 3 wherever I can see what? Wherever I can see x. Okay, so that would be 1 over 168, and then I had what? I had x to the power 4, that would be 3 to the power 4 over 4. Okay, and then plus 3 multiplied by 3, and then minus 13, okay, minus 13 over 4. So I just punch this onto my calculator. I'm getting 0.154761904. So you see that I get the same answer. So you can either use the CDF or the PDF to calculate these probabilities here. So let's calculate the second one there. Okay, we're also going to use the two methods that we've had. Okay, so now on number 2, they're saying find the probability that x is greater than 2. So what is this probability that x is greater than 2? Okay, so this is just the probability from 2, this guy, all the way to the highest value in this interval, which is what? 5. Okay, and then I put my PDF there. So this is the PDF method plus 3, and then dx. So from here I'll just get 1 over 168, and then I integrate this to be x power 4 over 4 plus 3x, okay, and then 5 to 2. So this will be 1 over 168, and then to be 5 to the power 4 over 4 plus 3 multiplied by 5 minus, now I start putting the 2. So there to be 2 to the power 4 over 4 minus 3 multiplied by 2, like this. So what's remaining is just to punch this guy into the calculator and then find the value. Okay, so we have 5 to the power 4 divided by 4, okay, and then plus 3 multiplied by 5, so that is 15, and then I have minus, okay, 2 to the power 4 divided by 4, okay, and then I have minus 3 multiplied by 2, so that is 6. Okay, so when I punch that value onto my calculator, it's giving me 161.25. 161.25. So whatever is in the brackets here has given me 161.25, and then remember I'm multiplying by 1 over 168, so I'm dividing here by 168. So what would that give me? So this 161.25 divided by 168, okay, it gives me this probability 959821428. So this is the probability that x is greater than 2. So we use the PDF. Let's now use the CDF. So the CDF, we always have to make sure that this guy has x less than something. So probability that x is greater than 2 by the complement rule, it's the same as 1 minus the probability that x is less than or equal to what? 2. Okay, so this guy we can find it by the CDF. So this will be 1 minus f of what? 2. So we have 1 minus, what is f of 2? So it means wherever there's x in that CDF formula that we found, which was this guy here, okay, from 1 to 5, wherever there's x here, we're going to put 2. That's what it means. Okay, so meaning that I have 1 over 168, and then I have what? And then I have okay, 2 to the power 4 over 4 plus 3 multiplied by 2, then minus 13 over 4. So this will be 1 minus, so this part here gives me what? Okay, so I just have to punch that onto my calculator, and I'm getting okay, I'm getting 9 over 224 when I simplify it. Okay, so meaning that my probability is going to be 1 minus this. So let me just punch that onto the calculator. So that is 1 minus, and then I have 9 divided by 224. So this again gives me 0.959821428. So you see that either we use this PDF method, the CDF method, the answer is the same. But for the CDF method, it's much better and it's much faster, and you avoid the integrating thing. Okay, you're going to avoid the integrating thing. So for number 3, yeah, you should try out the PDF method. So that is the probability that that x is between 2 and 4. So you try out this one. Okay, so this here simply means the integral from 2 to 4 of 1 over 168 and then x to the power 3 plus 3 and then dx. So when you integrate it, what you expect to find there should be what did I find here on my solutions? So what you expect to find there should be 0.39285571. Okay, when you use the PDF method. So just integrate and then put in those limits. But me, I'm going to use the CDF. So the CDF method for x is between 2 and 4 is equals to, okay, you say f of the larger number, which is 4, minus f of the smaller number, which is 2. Okay, so this is what we have. And then it means in this formula, okay, for the CDF, this guy here, we're just going to replace, okay, wherever there's x, we're going to put what? Those numbers, and then we're going to subtract. So I can put it here so that we can be seeing it. So that is our CDF there. Okay, so 1 over 168, and then in the brackets I'm going to have, so I'm just going to factorize this because I'll have it here and I'll have it there, right? So I'll factorize the 1 over 168, and then there I'll put 4 over 4, I mean 4 power 4 over 4 plus 3 multiplied by 4 minus 13 divided by 4. Okay, and then I'll say minus, and now start putting 2, so that'll be 2 to the power 4 over 4. Okay, plus in fact that has to also be minus, or we can say we put this in brackets like this because we are subtracting this, so that will be plus 3 multiplied by 2 minus 13 over what? 4. So this is what I have here. Okay, so let's punch this onto the calculator as well as punch this onto the calculator and then see what we are going to find. Okay, so I'll start with the first one. When I punch this onto the calculator, what do I get? So let me just write it on top here. So I'll erase this part. So I'll say 1 over 168. Okay, so when I punch which one now? When I punch this one, okay, or let me even be multiplying it by the 168. Okay, so let me punch this onto the calculator. So 4 to the power 4 divided by 4 plus 3 multiplied by 4 minus minus 13 divided by 4. Okay, and then I multiply by the 1 over 168 here. What I'm getting is I'm getting 79, 97, not 79, over 224. Okay, if you want, you can just get a decimal number here. It's also the fine, and then minus, and then this part here is giving me what? Okay, so 2, let me do it again, 2 to the power 4 divided by 4 plus 3 multiplied by 2 minus 13 divided by 4, and then I multiply by the 1 over 168. I'm getting 9 over 224 like this. Okay, and then I can subtract these now. So since the denominator is the same, this will just be 90 over what? 224, right? Oh, no. The 97 minus 9, that gives me 88. So this will be 88 over 224. And then just find the decimal now. So 88 divided by 224, that gives me 0.392857142. It continues to go. So you see that this one, the one that you find when you do the PDF formula and the CDF, they're still going to give me the same answer. Okay, so you can use any. All right, so meaning that you guys now are well equipped to find the last one. So the last one will be, so you should finish it up. So by the CDF method, this will just be f of 3 minus f of 2. Okay, should find this. By the PDF method, this same thing will be the integral from 2 to 3 of 1 over 168 and then x to the power 3 plus 3, okay, dx. So both of these should give you the following answer. So you should try it out. It should give you 0.1145833. So both here and here, they should give you the same answer. So we are done with the probabilities. So that's how you find them. Okay, we'll move on to the expectations and the variance. Okay, so here they're saying find the expected value of x. So remember, our defined PDF was 1 over 168 x power 3 plus 3, okay, for the interval 1 all the way up to 5. Okay, and then elsewhere it was just 0. So to find the expected value of x, the expected value of x is equals to the integral from the lowest point in the defined interval, so that is 1, all the way to the highest point, and then of x multiplied by the f of x, and then dx. So this is going to be equals to the integral of 1 to 5, okay, of x multiplied by 1 over 168, and then I have x to the power 3 plus 3, and then dx. So let's factorize the 1 over 168. I remain with the integral of 1 to 5 of x multiplied by this. So I will have x to the power 4 plus 3x and then dx. So when I integrate now, this will be 1 over 168, okay, and then the integral here will be x to the power 5 over 5. So you add 1 and then you divide by the new power, and then plus 3x squared over 2, and then the limits are 1 to 5. Okay, so that's how we find the expected value. So there I'll just have to put in the values now. So it will be 1 over 168, and then I put in the 5 first, so that will be 5 to the power 5. Okay, 5 to the power 5 divided by 5 plus 5 squared over 2 minus 1 over 5, or 1 to the power 5 minus 1 squared over 2. So this is what we have. Okay, so the rest is just to punch these things on the calculator. Okay, so try to counter check as well, but when I punch it on my calculator, it's giving me 3.9333. so this is my expected value, so I can write it there. Expected value of x simply 3.9333. okay, the next thing was to calculate, so this was D. The next thing is to calculate the variance. Okay, so we know that the variance would have to calculate the expected value of x squared, okay, and then use the formula for the variance, because variance of x is equals to the expected value of x squared minus the expected value of x, and then we square it. So this we already have, this is this, so we just have to calculate this. So expected value of x squared is going to be equals to, okay, 1 over 168, the integral from 1 to 5 of x squared multiplied by x to the power 3 plus 3 dx. So this will be the integral, oh no, it will be 1 over 168, and then the integral from 1 to 5 of x power 5 plus 3x squared dx. So this will just be 1 over 168, and then the integral here, okay, will be x to the power 6 over 6 plus 3x power 3 over 3, and then from 1 to 5. Okay, so just have to put in the substitute the limits there. So I have 1 over 168, and then 5 to the power 6 over 6 plus 3. So this 3 and 3 can cancel, right? So there we'll just have x to the power 3. So that is 5 to the power 3 minus, I start putting the 1 now. So it will be 1 to the power 6 over 6 minus 3. Oh, the 3 cancels, so it will just be 1 to the power 3. Okay, so what do we get there when we punch this on the calculator? Okay, so my calculator says that the expected value of x squared is 16.23809524. So that is my expected value of x squared. So I can put it somewhere here. Expected value of x squared is just 16.23809524. Okay, so once we have that, then we are good to go to find the variance. So the variance of x, okay, variance of x is going to be equals to the expected value of x squared, which is this 16.23809524, minus the expected value of x, and then we square it. Okay, so we just punch this onto the calculator and see what we're going to get. Okay, so let me do that. So 16.23809524 minus, then in brackets I'm going to write 3.93333 and then squared. Okay, so what I get there as my variance is 0.76701031. Okay, so that's my answer there. That's my variance. Okay, so we can keep this variance for future use somewhere here. So we can say my variance of x is actually equals to 0.76701031. Okay, and then the next one now will just be using a linear relationship of this expected value as well as the variance. So you can see here on f, they're saying find the expected value of 3x plus 5. So we're going to distribute this expected value. So it will be the expected value of 3x plus the expected value of 5. This one here will be 3, so the 3 goes in front, and then I remain with the expected value of x plus the expected value of 5. So this will be 3. The expected value of x is this guy, so that is 3.93333 plus, so the expected value of any constant is just the number itself, so that will be 5. So we just punch this now onto the calculator to find whatever we desire. Okay, so here the answer will be 16.8 if I round it off to one decimal place. Okay, so you can just do 3 multiplied by 3.93333 and then plus 5. Okay, it's going to give you 16.7999. So if you round it off, it just be 16.8. Okay, so that's how we can find the first part on f. And then the second part, where we're finding the variance of f of 3x plus 5. Okay, so this one, be very careful. It will be the variance of 3x, okay, and then plus the variance of 5. So now, when you put the variance and you want to put this guy to factorize it into the front, you always have to square this number. So it will be 3 squared and then variance of x. Now, the variance of a constant, okay, the variance of a constant is always 0. So this will be plus 0. Variance of a constant is 0. So this will be 9 multiplied by the variance of x, which was 0.76701031. So 9 multiplied by 0.76701031. Okay, so that would be 6.903093.159. So that is my expected value of x3 or 3x plus 5. Okay, that's my expected value. Yeah? Then let's solve the last one. So now the last one, we are told we have to find the expected value of 2x plus 2y, where our y is x plus 1 squared. So what we need to do here is first find this y in terms of the x. So if we square this, it will be x squared plus 2x plus 1. That is x multiplied by x, x squared. X multiplied by 1, I get x. And then 1 multiplied by x, I get plus x. So that's where the 2x is coming from. And then 1 multiplied by 1, I get this. So here, this expected value of 2x plus 2y is the same as the expected value of 2x plus 2. And then this is our y. So x squared plus 2x plus 1. Okay, so it will be the expected value of 2x plus 2x squared plus 4x plus 2. Like terms together, it will be the expected value of 2x squared. This 2x and the 4x, they form 6x and then plus 2. So this will just be, okay, 2, the expected value of x squared, plus 6, the expected value of x, plus the expected value of what? 2. So that's what we get there. Okay, so from there we're just going to put in the expected value of x squared, the expected value of x, and then find the final answer. Okay, so this simply means that my expected value of 2x plus 2y, which is equals to this, will be 2. The expected value of x squared is 16.23809524 plus 6. The expected value of x is 3.933333 plus, here I have the expected value of what? Oh, this has to be 2. Why did I write x? Because this is 2. So that is the expected value of 2. Okay, so we just punch this onto the calculator and obtain the value. So the value is 58.0752,381. So this is the expected value of 2x plus 2y, given that my y is given by this guy here. Okay. Okay, so if you'd have to access the full solutions to this tutorial sheet where we're solving all the questions here, okay, you can see all the questions here, we've solved them, and the videos are available on our website, okay, which is discretelearning.com. So you can actually subscribe and then you can have access to all these. Okay, so in the link in the description below, you're going to find a link that has the video registration guide, so you can watch it and get to learn how you can subscribe. Okay, and then in that same video, we also tell you how to use our mobile app. So our mobile app, you can download it from Google Play Store. It's just discretelearning.com. I mean Discrete Learning Institute. Okay, and then once you have the app, on that mobile app, you can even download the videos and you can watch them offline at your own time. Okay, so once you register and then you go on our website, you need to see something like this. Let's let it to load. Okay, so this is our website here. So when you register, you see something like this. So if you're on that tutorial sheet, you register for this course, which is mathematics, and then you go in this folder here for probability and statistics. So you open it. You're going to find different folders. So you go to the tutorial sheets and assignments here. Okay. And then that tutorial sheet is for July intake. So when you go to the video solutions, you have to go to the July intake part. Okay, so just wait for it to load. Okay, so once it loads, you see that we have different intakes. Okay, so you can even use the videos for the other intakes. Okay, we have full tutorial sheets here. You can see from 1 all the way up to 6 on different topics. Okay, so the first one, that's just like descriptive statistics, and then we go on to the probability, discrete random variable, continuous random variable, and also estimations. Okay, sampling and estimations, even hypothesis testing. And then for this one here, you go in the 2025 July intake. You're going to find all the tutorial sheets there. So that was tutorial sheet 5. You're going to find 1, 2, 3, all the way up to 5. Okay, so thank you so much for watching and bye-bye.